Problem 3, Part A. Find the Maclaurin polynomial of degree 4 for f of x is equal to cosine of 4x. So we need to find multiple derivatives, and we have the cosine of 4x evaluated at 0. We're using 0 because it's a Maclaurin polynomial, and Maclaurins always have a center of 0. And you get a value of 1. Finding the first derivative, making sure you use the chain rule, we get negative 4 sines of 4x. Plug in 0, we get 0. Double prime, negative 16 cosine of 4x. Plug in 0, we get negative 16. Triple prime, 64 sines of 4x. Plug in 0, we get 0. And lastly, the fourth derivative, 256 cosines of 4x. Plugging in 0, we get 256. Using the formula for the Maclaurin polynomial, we get 1 over 0 factorial plus 0 over 1 factorial x minus 16 over 2 factorial x squared plus 0 over 3 factorial x cubed plus 256 over 4 factorial x to the fourth, using the values from up above and just putting them in the corresponding places. Simplify, p sub 4 of x is equal to 1 minus 8x squared plus 32 over 3 x to the fourth. Part B, find the Taylor polynomial of degree 4 for f of x is equal to cosine of 4x at x is equal to pi over 2. So we have a different center, but the derivatives are still going to be the same. So cosine of 4x, when we put in a pi over 2, we get a value of 1. For the first derivative, negative sine of 4x, we put in pi over 2, we get 0. Negative 16 cosine of 4x, we get negative 16 when we plug in pi over 2. 64 sines of 4x, we get 0. And 256 cosines of 4x, we get 256. And we use the polynomial and put in the values. And so we get p sub 4 of x is equal to f of pi over 2 or 0 factorial plus f prime at pi over 2, 1 over 1 factorial, and etc. So simplifying that and putting the numbers, we would have 1 over 0 factorial plus 0 over 1 factorial x minus pi over 2, then plus a negative 16 over 2 factorial x minus pi over 2 squared, plus 0 over 3 factorial x minus pi over 2 quantity cubed, plus 256 over 4 factorial x minus pi over 2 raised to the fourth power. Finally simplifying, we have 1 minus 8 x minus pi over 2 quantity squared plus 32 over 3 x minus pi over 2 quantity to the fourth. Now let's look at the accuracy. Part C. We're going to take a look at the cosine of 1. Make sure your calculator's in radians, and you get 0.5403. Now using the polynomial is a little bit trickier. We're using p sub 4 of x from part A to find the cosine of 1. But remember that this p sub 4 of x represents the cosine of 4x. So that x would have to be 0.25. So given the cosine of 4x is approximately p sub 4 of x, which is 1 minus 8x squared plus 32 over 3x to the fourth, the cosine of 1 will equal the cosine of 4 times that x of 0.25. So when we go to the polynomial, we have to put in p sub 4 of 0.25. And we plug it in 1 minus 8 times 0.25 squared plus 32 over 3 times 0.25 to the fourth power, and we get a value of 0.5417, which is pretty close to 0.5403. This is again a Maclaurin polynomial, so 0.25 is pretty close to the center of 0. However, if we look at the polynomial we got in part B, which has a center of pi over 2, well, 0.25 is pretty far away from pi over 2, which is about 1.5. So we take a look, and again, you use 0.25 for x. So the cosine of 4x is equal to p sub 4 of x, which is approximately equal to 1 minus 8 paren x minus pi over 2 squared plus 32 over 3 x minus pi over 2 to the fourth. Cosine of 1 then is cosine of 4 times 0.25. Running 0.25 through this new polynomial, we get an answer of 19.5057, which again is very far away from our calculator answer because we just moved very far away from the center. And in part D, we look at the cosine of 8. Now 8's pretty far away from 0, and we have a cosine of 8 in my calculator using, again, radians as negative 0.1455. Beginning, we have to be careful using p sub 4, which is the cosine of 4x. We have to let x equal 2 when we put it into the polynomial. So we have cosine of 4x is equal to p sub 4 of x is equal to 1 minus 8x squared plus 32 over 3x to the fourth. Again, to find the cosine of 8, we have the cosine of 4 times 2, so x has to be 2. So we put 2 in our polynomial, and we get a value of 139.6667. We run onto our other polynomial, which is centered at pi over 2. Now, pi over 2 is about 1.5, so that should be a little bit closer to the value of the calculator. And we get the cosine of 4x equaling p sub 4 of x, 1 minus 8 times the quantity of x minus pi over 2 squared, plus 32 over 3 quantity of x minus pi over 2 to the fourth. And we again plug in a value of 2, and we get an answer of negative 0.1117, which is reasonably close to cosine of 8 in your calculator. Question 4. You want to build a polynomial to find a reasonably accurate value of e to the 1,000 power. Name 2 ways that you could build the polynomial. Well, if you change the center to x equals 0, then you'd have e to the 1,000 power would equal e to that center. Or, if you didn't want to change the center, you can make the polynomial much longer, because you have to get out to have it match up e to 1,000.